Hello guys, my name is Diego Pacheco and today I want to show you a project that I built. I'm calling like a constellation of microservices. So basically I wrote several microservices, 5 microservices, each one in a different stack. So there's one in Scala, there's one in Java, there's one in Ghost, there's one in Python, there's one in Rust. And I'm gonna orchestrate all together and run it in Docker and in Kubernetes. So let's get started, okay? So first of all, I'm gonna open my console here and I'm gonna open the project, all right? So this is the project I have. As you can see, we have 4 mathematical services. So we have a division service written in Go, we have a multiplication service written in Java, subtraction service written in Python, a sum service written in Rust, and an aggregator which does the Polish notation math written in Scala with the Polish notation algorithm. So let's run this on Docker Compose, okay? So we're gonna do Docker Compose up. Um, so we'll boot it up all the services. Let's wait. So we can see here on the logs that all the services is running. We can see some Spring Boot log. We can see some Flask log from Python. Here we see some Go log using Gingonic. And also we see some Rust logs here, and that's the thing. So let me open a new tab, and then I can do Docker Compose PS, and we can see that our 5 microservices are running. I can also do Docker PS, and I can see I have 4 services up and running. So I have a bunch of bash scripts here to help us to figure out what's going on. So I have this script here called test docker compose, right? So we can take a look. Basically what we're gonna do here, I'm gonna use docker inspect to get all the IPs of the 5 microservices. So here I'm getting the sun IP, the subtraction IP, the multiplication, the division, and also I'm calling the aggregator, doing all the things together, right? So we can simply just run this script. Test docker compose is this one here, okay? And we can see that, oops, okay, there we go. As you can see, it's working. I call all those services, and it's all good. So now let's run this on Kubernetes, okay? So let's stop it. I'm gonna do a docker compose down, gonna shut down all the services. Alright, so all my services are down. I can take a look here, they are stopped. I can do docker ps. I also can do docker compose ps. I can see it's all stopped. In order to run this on Kubernetes, I'm gonna use MiniCube. So I have a bash script called create MiniCube. So we're gonna use a feature in MiniCube called profiles. There's an interesting blog post on my blog if you want to know more about it. So basically I'm saying I want to start a VM with 8 gigabytes. I want to use 4 CPUs, and I want to call this profile as Calc service, right? So let's run this, create MiniCube. So we'll create MiniCube is Kubernetes image for us. In this case, MiniCube is running on version 181 and using Ubuntu 18.04 with the latest version of Kubernetes. So let's just wait while our profile is being created and the image is being booted up. So let's just wait a little bit. After running this, we're gonna deploy the services in Kubernetes. While we wait a little bit here, let me show how we're gonna do the deploy. So basically I have this script to do Kubernetes deploy. Let's take a look on it. So basically what I'm doing here, I'm using kubectl with the apply command, and then I'm passing all the specs for the microservices. So I have the specs for the aggregation service in Scala, the division in Go, the multiplication in Java, the subtraction in Python, and the sum in Rust. So basically with this script, we're gonna create deployments, replica sets, and services and pods in Kubernetes. So let's wait while this is created. If we take a look on VMware, we can see, let's see if it shows yet. No, it's still not here. Still not showing up. Oh, now we go. Now it's creating Kubernetes. So maybe it appears now. It takes some time. For you, it might take even longer because you might need to download the whole thing from the internet. As you can see, I have MiniCube VM here, but this is the default profile. When you don't pass -p, it goes this one, and I have other profiles. But okay, it's done. So maybe we can check here. Yeah, for some reason it's not appearing here, but that's fine. So we can check if it's all good. If you do, I have an alias for MiniCube, but just do m, right? But I'm doing MiniCube, so I can do MiniCube status -p, and then it's Calc services. Yeah, they are running, right? And I also can do kubectl. I have an alias called K for short, so it will do get all is working. Just to see I'm not tricking you, kubectl get all right? Yeah, there we go. Okay, so we have MiniCube up and running. Now we can do the deployment, right? So we can do deploy Kubernetes. Okay, and now we can do some interesting thing, like we can do kube ctl get all. So you can see the replica sets are created already, the deployment and the services. And now we are creating the pods, which will take time because we'll download the image from the internet. So what we can do here, we can use this watch command in Linux, -1, and then this will be refreshing every 1 second, so we can monitor it. So let's monitor while the containers are being created. And then once they are created, we can do a test, and then we can see the source code. So let's wait a bit. For some reason, it's not listing here. Strange. It often appears here. I don't know why it's not appearing. I don't know how can I refresh. There's a refresh here. Yeah, never mind. I'm doing that all the time, creating and deleting profiles, so maybe that's why it freak out a little bit, but it's all fine. Okay, so our aggregation service is running, as you can see here. And the other 4 math services are being created. So let's wait a little bit. This will take some time because it's downloading all the Docker images from the internet. Let's wait. Okay, so we have the division written in Go service running, and now we have the multiplication in Java. So we're just waiting for Python and Rust services to kick in, and then we have everybody running. Okay, we have the subtraction service in Python running, just waiting for the Rust one. This is the last one to go. Okay, so we have all the Service is up and running. Now we can test this, okay? So one thing I'm gonna do is port forwarding. So let me show you this script. So basically in Kubernetes, I'm gonna get a pod, the one that's running the aggregation in Scala. So with this command here, I'm gonna figure out the pod, and then I'm gonna use JSON path, and then I'm gonna be able to get the name of the container, okay, and then I'm gonna forward the 8090 port to my 890 port. So in this case, I can do a local access. So if we go port forwarding, let's run it. Okay, so the port is forward. So if I want, I can double check it. So I can do sudo netstat, and then I can grep for this port, put my password. Yeah, we can see that kubectl opened that port is being forward. Now I can test thing. I have a script here to do the testing for Kubernetes. So here I'm doing a single request. As you can see, I'm putting localhost because I'm doing a port forward here. So I'm gonna call my aggregation service written in Scala, and I'm gonna pass a equation in Polish notation. So I'm doing 1 plus 1 multiplied by 5, the result multiplied by, sorry, sum with 5 multiplied by 20 minus 50. So I'm passing this equation here, and I'm gonna get the result. So let's try to run this K8s aggregation. Sorry, K8s. What's the name? Test. Sorry, test/test. Yes, this one. Okay, so we can see it's working. So we have the solution working on Kubernetes. It's all good. Also, we can see some dashboards if you want. There's a script for it. I can do MiniCube add-on dashboard. I just need to pass the profile, and then we can see Kubernetes dashboards for it. So I can do like this. We enable the dashboard and launch on my browser. There we go. So we can see here my services. We can see Sun in Rust, aggregation in Scala, division in Go, multiplication in Java, subtraction in Python. We can see the pods. I can see the logs. I can see lots of information, like I can go to Rust here. I can grab more information and events. Okay. All right. I can see the deployments here as well, and also if you click in, let's say, someone here, you can get the deployment informations and events and much more information. Also can see the services that we have here, and then you go on the service, you also have the pods that are registered to the service. Pretty neat. Great. Okay, so now let's take a look on the source code. Okay, so I'm gonna open my VS Code here. So here's the main project, okay, with all the scripts you saw. So let's start with the Go one, right, which is pretty simple. I just have a file called main.go. I'm importing Jingonic here. I'm creating a service with Jingonic. I'm saying /service/div, and I'm getting two query parameters called VA and VB. Then I'm getting the string and parsing into float of these numbers, VA and VB. Then I'm doing the division. And once I do the division, I'm returning this as JSON with the HP states code for this result. I'm running the server on the port 6000. I have the Docker file. So basically here, I'm using the Golang 112 Alpine. Then I'm installing Jingonic, installing Git, removing Git after installing it, creating a application folder, copying the source code, and do go build, and then run the Go application as a single binary. So I have a script here if you want to run with Go, and also if you want to install the dependencies, there's a script here. So if you want to run local, so let's go. Let's take a look in Python. So Python here, we pretty much have a app.py file. So I'm using Flask here. Flask is like a Sinatra-like, like Express in Node.js application. So I'm running on debug mode. Then I'm creating a halt saying service sub, getting two query strings VA and VB, converting to float, doing the sum, and printing for debug purpose, and return the response. I'm running this as a local host application. By default, it is going to be port 4000, 5000. For requirements.txt, that's how you manage requirements in Python. I'm adding Flask dependency, the version I want to use. I also have a Docker image, so I'm using Python Alpine, Python 3. So I'm creating a folder for the application. I'm doing a pip install -r requirements to install the dependencies, exposing the port 5000, which is the default from Flask, and I'm using Python to run the application. I also have a script to build the Docker image, and also I have a run script if you want to run it locally. So that's Python. Let's take a look in Rust. So in Rust we have a cargo project. So you need to look cargo.toml. I'm using Hyper and Tokyo as the servers to run this. And then if we go to src main.rs, we have our Rust application. So here we have a function that we're going to return either a result with a body or a hyper error. So we are mapping a service /sun, that will be our REST URL. Then here I need to do this, all right, in order to get the query parameters as a hash map in Rust. So sorry about this code, but that's what I need to do. So basically I get the request, I get the URI, the query, and then I have a map operation to parse the values and create key value pairs and put in a map. So that's why I get the parameters. Once I get the parameters, then I can do get the two numbers VA and VB. In Rust you need to do this one wrap because the get operation we're going to return an option. So I need to unwrap to get the value of the option. So I'm wrapping here VA VB. Then in Rust there's standard conversions. I can parse the number and saying I want a float of 64 bytes. This option as well. I need to unwrap it. I parse it 2 times. I do the sum. I get the result. I print the result and also return the response. All right. And here is just the bindings. I'm creating an async main using Tokyo. Then I'm binding the server to localhost, accepting any connection outside of the box. By default, using the port 3000. And this will give us the address. Then I can build the service using the function. I have it here. And finally, I can run the server and just wait for requests. That's the code in Rust. In Java, so we have a Gradle project. This is a Gradle 6 project. So I'm using Spring Boot here, version 202. And basically here I'm using Java 8. And there are a couple of dependencies like log4j for login, and Spring Boot for the server, and using Spring as IOC and DM server. So if we go to src main Java, you're going to have an app. It's how you configure a Spring Boot application. You need to use the Spring Boot annotation and the auto configuration package, so it will scan all the modules for us, and then we run this application. So I have a controller called mul controller, which I use the annotation at rest controller. I'm using log4j for logging, and I'm mapping a get URI. So I'm saying if you hit /service/mul, then this code will run, and I'm getting 2 request parameters, which is VA and VB. Okay, and in this way, this will be query parameters. and then I get the value as a string. I'm parsed to double it, do the multiplication, log it, and return the result. That's it, the Java code. Now we can look the aggregation in Scala. So here we have a SPT project. So if you take a look here, we are using SPT version 137. There's a plugin here, but I'm not really using much. But it's the assembly, so I can pack a single binary. So I have the build.spt, where I'm using Akka, which is an actor framework. I'm using Akka HTTP in order to make this work. This is the assembly configuration to generate a single jar. Okay, this will generate the Aggregator Scala jar, so I can run as a single jar. I have a bunch of scripts here, like to run all the Docker services in my machine using Docker, to run, the aggregation, to run the service alone with just SPT, and to test it. You can see I'm passing several variables. I'm gonna show you Kubernetes. You understand why. So on the source code, I have the app, which is I need to create an actor system in Scala and a materializer in an execution context for the threads. Basically, I'm getting environment variables for the sub, mul, div, and sun services. So I don't have the IPs and the URL hard-coded here. I'm receiving this via environment variable. And then I'm adding this to this object called solve RPM. We're going to see it soon. Then I'm creating a halt, just saying service, expecting a parameter called math, and then you can pass a operation, and basically I'm gonna call my object to solve the polish notation, passing this math, and we're gonna return the result. And here I'm hooking the server to run localhost with the port 890. So if we take a look at this class, this is where we do the magic. So this object, which is a singleton in Scala, we pretty much have the four other services URL. We have a get operation where I'm gonna call the services based on URL. We have a call operation where I receive the operation and the values. So I mount the query string because all the services, they have the same base path, and then like the parameters are the same as well. So I just need to know which operation is the base one, if it's a subtraction, if it's a sum, if it's a division, and the rest is the same. And then I call get, so I do the rest call using Scala source to do it, built in from Scala, no external libraries needed to do it. And then I get the result and I convert to double. So my polish notation solver, pretty much what I have here is I have the solve method where I'm gonna get the string, I'm gonna split it by space, and I'm gonna have a accumulator of values that will be a list of doubles. Then I'm gonna go for all the items, split it, all the values that could be either a mathematical symbol like plus, minus, subtraction, division, or a double value. Then I'm gonna folder left, which means I'm gonna do a for, and I'm gonna accumulate the result of this function in the accumulator, right? So this function here is downstairs, and then I'm gonna return the head, the value, the single value resulted from the accumulation. So this is in other language like a reduce function, if you are familiar to Clojure, for instance. So on the folding function, I get a list of values, which is a stack, right? It behaves like a stack, and I have a string, and I'm gonna return a list of values as well. So I do a pattern matching on the stack, and if I'm getting a list, then I wanna get the string and convert to double and add to the stack. If I get a list of something, I also wanna convert to double and add to the stack. Otherwise, I'm getting an operation, right? So in these two cases, we are pushing to the stack. In this case, we are popping from the stack. So it's time to do something, because means, let's say, imagine you have the string 1 space plus, all right? So that's the string you have it. So first of all, you're gonna get here, and then you're gonna have 1. Second time you're gonna get here, you're gonna have 1, 1, and then you get plus. Then it means we need to pop 1 and 1 and send it. So we're gonna get the the value x and y, which was the previous ones. And what we want to do is check the operation, all right? So if the operation is a plus, we want to call the multiplication service. If it's a multiplication, sorry, asterisk. If it's a plus, we're going to want to call the sum in Rust. If it's minus, we want to call the subtraction in Python. If it's division, we want to call the go service. So we pass different URLs that we have stored here. So it's all dynamic, nothing hard-coded, and we pass the values. And then the service will return a number, which we're going to add to the stack again. And we do that until we just get one value, right? And that's how it works. That's how the engine works. So that's the code. Let's look at the specs, right? So how we deploy it. So let's take a look on Sun. So we have a deployment where we are saying we're going to use this image. This is on internet. This is my image that I pushed to my Docker Hub. If you do a Docker run with this string in your machine, it will work. I'm saying how much memory I use and CPU and the port that I want to bind for the container. And then I have the service. I'm just forwarding that port as a service port, right? And I'm using as a cluster IP. That's kind of boring because that's the same thing for Python. So if you take a look, I have the deployment. The only thing that changed it really is the name of the image, and in the service, the port, all the same, and the names, of course, right? The multiplication, I have a very minor difference, which is the memory, because it's Java, right, guys? So I'm using 1 gigabyte. If you don't have too much memory like I do, you can reduce this. It should be fine. And here I have the service for Java, and here for Go, the same deal. So I have the image for Go, the port 6000, the same for the service. And then I have the Scala one. This is the interesting one. So on the deployment, I need to say where are the other services, all right? And that's the cool thing about Kubernetes. Kubernetes has a default DNS. So I don't need anything like Eureka because Kubernetes has it built in. So basically it will be the name of my service, then the namespace. So I'm not setting anyone, so it's default. You can check that if you do cube ctl get name spaces, and then you're gonna have a list of namespaces, and you can see default. When I did key get all, which is cube ctl get all, you see our services, so they're really running on the default namespace. I can do -o wide. You're gonna get more information here. All right, so so the same pattern goes for all the services. So I basically just changed the name of the service here, right? And I have the default svc cluster.local, and then I just put the port and part of the REST URL, and that's pretty neat. And then the service is like the same. I just bind the port. If you remember, I showed some Docker Compose here. We have similar deal here. So we have the image for the sun, multiplication, sub, and div. I just have the image and the port. And for the aggregation, I need to say I depend on all other services. They need to build up and to run before, and also I'm linking to all of them. And then Docker has a DNS too, which is the name of the container, right? So in this case, it's sun, mul, sub, and div. So I just go here and I change just sub and then the port, right? So we have the same video. I'm passing environment variables, and that's how cool this thing is. So that's it pretty much, guys. I hope you like it. See you next time. Cheers.